Repeater or wireless mesh system? What should I buy? Are the questions of customers when they are standing in front of boxes in the shop. What is the best system for your wireless extension? We clarify in this Ask Ellie episode. Repeater or wireless system? The difference in prices and functions is enormous. In this episode, I want to show you what is the best choice to extend your wireless among your home or in your company so that you can have the best access and the fastest wireless speeds we can get with our products. Let's see the graphics. Let's have a look at the standard situation in most of the homes. You have an internet access device that often comes with an own wireless, but you need to bring the wireless through your whole home. So there's an option to use, of course, a repeater that can bring the wireless directly to a client or spread it in your home. But the main problem is that because the 250 megabits that will be delivered by the router are on the hop number 2, so we jump from one device to the next, are often half of it, so it's less than 125 megabits. If you take another repeater, the speed is even lower, and if you take a fourth one, the speed is only a quarter of what you receive from your internet access. And even if you connect a device by LAN cable with 100 megabit per second, the speed is not higher than what the device receives. The reason is that each of the repeating devices is a client to the wireless that is in front of it, and they don't know each other, so there's no interaction between these devices. It's a simple access point and client relation. Different is a wireless mesh system, which is often the first node is connected to your router by a Ethernet cable, and then you have 100 megabit or 1000 megabit already at the uplink port of the wireless system, and then you can have a system that is meshing in the nodes together to a big wireless cell and has the speed that the wireless system promises. Mainly here it's been, when we use the multi M1, it's 1800 megabit per second. That's the main difference. I can show it in the graphic to you. So here is what I wanted to explain to you. There's a Wi-Fi mesh system that covers a whole area with only 2 devices, and it brings a big wireless cell that has a slight overlapping, so the client has the same wireless in every segment of your home. If you compare that with the usage of repeater, the client has to lock on to each repeater's wireless when it's moving in the direction, and the more you have distance from your internet router, the lower is the speed and the wireless signal at that point. So you might lose 75% of your internet speed by using multiple repeaters instead of a wireless system. If you see the boxes of some devices, you often see the number of antennas and also the kind of antennas that is mentioned. So here it's a high gain standard antenna on this device, but you also have devices with smart antennas. I will show you the difference, what this means. On the boxes of the devices, you often see the number of antennas used, for example 2.2 or 3.3. What is the difference for that? In first state, the device that has only one antenna can use a connection to the access point for sending or receiving data between access point and client. If you have a 2x2 antenna, you can have double speed, but you can have send or receive connection. And using a 3x3 antenna system, you have 3 antennas for sending and receiving data. In the standard system, this is only a one-way direction. A reliable data at a low speed, and the diversity of the antenna is often reduced. If you combine that, so you have a beam for receiving and sending data, it is at a high speed, but the reliability is less. So we call it spatial multiplexing. By combining this method, it's the hybrid method, you have both and at an average speed, and the connection of a 2x2 device is better. In the real world, these 2x2 devices meet the same issues as a single antenna because sending and receiving can be destroyed or disturbed by reflections or objects that do not allow wireless to pass through. If you now use a multi-input, multi-output, so-called MIMO, which is also seen on the boxes, you can combine two antennas by sending and receiving on a more reliable system. Then with a 3x3 antenna, you can even increase the number of antennas using the access point, so you have 10% better coverage. Let's see how this works in an optimized environment. A normal antenna has a direction that is with diversity in a circle way. Every object that's in its way will disturb this wireless. Also, you cannot change the antenna. For example, if you want to mount it on the wall, you have interferences between different floors. Using a dual optimized antenna knows which mounting direction is chosen, so either wall or ceiling, and if it's on the wall, it changes the diversity that it's only going in the direction of the floor it should service. And the optimized way is a smart antenna, because smart antenna, the name says already, is able to change its behavior. The smart antenna is not a beamforming, it changes the steering of the RF energy. Let's see the single antenna. It has a standard pattern of normal signal. The more distance you have to the access point, the worse the connection is. While a dual antenna, you have an overlapping pattern that has a very good receiving and sending position at a specific point. We call it the phase amplitude. And if you're using a smart antenna, dual antenna with a moving phase, you can choose where this position in the overlapping of the signals should be. So Wi-Fi quality of experience is our key to service you with our products. But many customers meet problems in the normal environment. For example, the most asked questions are that they have installed a sufficient number of access points, but still the clients are complaining about disconnection, interruption of the Wi-Fi or very slow Wi-Fi. But why do these issues happen? That can also be in your normal home, but also in a company. Well, on the 2.4 GHz spectrum, we have a channel broad of 20 MHz. That means if we have a bandwidth between band A and band B, you have the 802.11a band with, for example, channels from 36 to 64 that have a width of 20 MHz. So the number of channels is big, but the number of clients that should be in this spectrum is reduced. If we have the 802.11n system, it has a much wider channel width for 60 MHz, but the number of channels is not so various, so that clients have to find the optimized channel. And in the higher segment 802.11ac and the 802.11.ac wave 2 or AX, the channel width is increased to up to 160 MHz. That means that we have a big number of clients that can join the same channel and they do not see interferences because of the high megahertz. And also the opportunity is to move down the channel width up to, for example, 20 MHz only to have a slower but reliable connection to the access point. So what is the issue basically? Using this should be fine, but if your access point density is too high, you meet the problem that the channels are not working smoothly together, like this example on a motorway, you will see that the packets, which are now drawn here as cars, have collisions by moving towards the access point. In the real world, it looks like this. You've installed an access point with a standard antenna that has a normal diversity, and it's sending out to a limited area of clients. If you put in the second access point, this will overlap the first one, so you have a channel interference, and that means collisions between the access points, and the client flip from one access point to the other. By reducing the radio of the overlapping access points, you will see that the number of collisions is reduced, but the clients that are more distant to the access point do not have internet access anymore. The solution that we offer with many of our products is a smart antenna. So if you're checking for wireless systems or access points, just check if they have a smart antenna. This is a device that has more antennas, and they can change the diversity of these antennas. That means that if they are mounted, for example, on a ceiling, the smart antenna does not have a round pattern of diversity, so it's dynamic. And even if it's mounted to the wall, it can have a 90-degree pattern, so the device can beam in the way of frequency towards the distance where the clients are. In real life, this looks like if the smart antenna device is installed in an environment, all clients are served with wireless, then we see there's a distortion. For example, somebody is using the microwave in the kitchen to heat up his lunch. The microwave starting interferences with the access points, and suddenly the clients that are distant from the interference do have internet access. Immediately when the smart antenna notices that there is a distortion, it uses more than 700 patterns of diversity to find the best solution to service the clients that are away from the distortion and get internet access immediately back, so there's no interruption. So using wireless devices, wireless access points with a smart antenna is the optimized system to spread your wireless hassle-free among the company or in your big home. If you want to know more about our products, there's a new way of getting the information which is on our website. Just take a look on our website Zyxel.com, and you can see in the upper part there are 9 bubbles for applications. The application is under My Zyxel and others. You can find a store, and on this store in Europe you can find our products that are offered for a very good price, directly sold to you. There are also the information about the devices, capacity and features, and you can order right away from this point. If you have a question about the product, then do not hesitate to subscribe to our channel and send your question in the comment segment. I will try to answer it very short time. Also, you can follow us on Facebook. We are done with our episode from Ask Ellie, what should I choose, repeater or mesh system? So thank you very much for watching and have a nice time.
We're Zyxel, and we're your networking ally.
You can't get enough of Zyxel videos? Well, I can understand that. Then subscribe to the channel and hit the bell to get notified when we upload new content.